Hi everyone, and welcome to the Density and Measurement Lab for Chem 101. First things first, safety. We always want to wear our chemistry lab safety goggles when we are doing our chemistry labs. Now, technically, we don't need goggles for this lab. The only material that we're using are solid cubes of metal and water, which are safe. But it's not a bad idea to get in the habit and sort of get in the spirit, the chemistry spirit. So the things you're going to need from your kit, you're going to need your 25 milliliter graduated cylinder. You're going to need your digital scale. You're going to need the ruler and the little cube of metal from the little snack size Ziploc bag. And you're also going to need some water. I have mine in a squirt bottle, but you can just use the tap or a cup. I'm going to angle this down so you can see everything. All right, so we're in this lab, you're going to be measuring the density of this piece of metal. It's a known piece of metal. There's a stamp on one side that tells you the identity. I have lead. And you're going to be measuring the density by measuring the mass and volume. And you're going to be comparing the density that you calculate through your measurements to the known density of that metal. And you'll be performing some statistical analysis as well. So the first thing that we need to talk about is the digital scale. So the digital scale is both battery operated. It takes two AAA batteries, or it is USB operated. So there's a little port here where you can plug it in using a USB charger, and you can plug it in to your computer, your phone jack, and not need batteries. So either way, you're going to need to charge it up. And then once you have added electric charge to it, you can turn it on. It'll say hello, and then it should report all zeros. If it doesn't report all zeros, you hit the tare button here, and that will return it to 0. It's very important that you have your digital scale on a flat and non-wobbly surface. If you can't hold the scale in your hand, don't put it on a textbook on your bed. Don't put it on a table or a chair that wobbles. You want to put it on a solid counter or the floor or a desktop in order to get accurate measurements, okay? And all we're going to do to get the mass of our metal cube is just put it directly on the scale. We're going to record all of the digits that show there. All of them are significant. It reads to that many figures, so that's what we're going to record. And then we're done with the mass. And we're going to use that mass in both the first and second part 1 and part 2 of the lab. The difference between the two parts is how we're obtaining the volume, how we're measuring the volume. So in part 1, you're going to be measuring the volume of this cube using a ruler. By taking measurements, you're going to use the centimeters side of the ruler, excuse my Band-Aid, and you're going to measure 3 sides of the cube so that you can calculate the volume by length times width times height of the cube. They should all be the same, but I don't know, these are pretty cheap, so they might not be. In part 2, you're going to be taking the volume through water displacement. So the way that works is, and Archimedes kind of made this concept famous in his bathtub. So you're just going to put about 10 milliliters of water in the graduated cylinder. I'm using a squirt bottle, but again, you can use the sink. The exact amount is not important, how much you use. What is important is that you record the exact amount. So I'm going to get down on eye level with the meniscus so I can get an accurate reading. I'm going to have the graduated cylinder on a flat surface. And I'm going to say we have 10.55 milliliters. So I would record that volume. Now I'm going to add the cube of metal to the water. I'm going to slant the cylinder because this cube is heavy and it's going to splash if I drop it in like this. So I'm just going to slide it down at an angle to avoid too much of a splash. And now we have the cube in the cylinder and the water volume has gone up. So again, I'm going to put that on a flat surface. I'm going to take that reading. I'm going to record that volume. And that volume change represents the volume of this cube. And so that's how you'll get the volume for part 2. And then you're going to compare the precision and accuracy of these two different methods. Now when you are done, you can dump the water down the sink. I have a sink over here. And get a paper towel and dry off your metal cube so that it doesn't oxidize too badly. So make sure it's nice and dry before you put it back in your kit. Don't lose it. I need this cube back. The end.